Greetings to you all. I'm so happy to come your way once again. Today's class is going to be an exciting one. I'll urge you all to get your pens, your pencils, your calculator, and any item that you need as we go through today's lessons. We are going to continue from our previous section, and today, as I said earlier on, we are going to do more calculation. It's going to be an exciting one, so let's all make sure you follow me as we go through these calculations. Now, before that, let's look at a quick recap over what we did in the previous class. Now, in our previous class, we've been able to define a circle. We've also been able to define some parts of a circle. I told you the definition under the parts of a circle. I didn't define everything. The ones we need for circle theorem is the ones that I gave to you in your definitions. There are other parts that we'll look at under mensuration. We also looked at the meaning of the word subtend, and I explained that the meaning of the word subtend means that it is holding. So to subtend means to hold. Now we started by looking at the theorems one after the other, and I said we are going to treat 9 theorems under this very topic. Now we started by looking at theorem 1. Theorem 1, we say, states that the angle that a chord or an arc subtends at the center of a circle is twice the angle it subtends at the circumference. So we said we are looking at a connection between angles subtended at the center and angles subtended at the circumference by the same chord. And the relation is that the one at the center is twice the one at the circumference. I gave you lots of examples on that. I even gave you a question for you to try your hands on them. But before we start with the calculation, we'll look at the connections once again. Then from there, I'll put some questions on the board and then we solve it together. So we're able to explain that for any given circle, assuming this is the center O, and we have a chord in the diagram. Let me call this chord PQ. Now remember, we said a chord joins 2 points on a circle, which we've already explained. So the line joining the point P to the point Q is what we term as the chord. And we said a chord subtends angles at 2 places in a circle. One, I said it can subtend an angle at the center, and 2, it can subtend an angle at the circumference. Now, if we take a look at this angle, so you realize that the chord PQ is subtending the angle O, and we explained that how do we know it is subtending the angle? And I said if a chord is subtending an angle, the lines that create the angle are going to have a connection with the chord. So look at the chord PQ. The angle here is angle O. You realize that for angle O, the lines which creates angle O is this line and this line. So you realize that for the 2 lines, one has a connection with the point P, and the other also has a connection with the point Q. So the angle O, you realize that the legs of the angle, or the lines which creates the angle, are standing on the line PQ, or the chord PQ. So in other words, PQ is subtending, if you follow my hands. So you realize the angle O, one leg at P, the other leg at Q. So PQ is subtending O. That's what we said. And we said O is at the center. So PQ subtends O at the center. So assuming you have a point here R, if I join the point Q, to the point R and the point P to the point R, again we explained that the line PQ is also subtending the angle R. And I explained that to know that it is subtending it, the lines which create angle R should have a connection with the chord PQ. If you look at angle R, these two lines create the angle R. This line and then this line. You realize that for this line, it has a connection with P, and this line also have a connection with Q. So PQ here is subtending Q. And it's subtending Q where you realize that it's subtending R, and it's subtending R where you realize that R is at the circumference. So chord PQ subtends angle R at the circumference. So one chord, the chord PQ, the same chord PQ is subtending angle O at the center. The same chord PQ subtends angle R at the circumference. So I said when you see something like this, then it means that there is a connection between the angle at the center and the angle at the circumference. And the connection is that the one at the center, the angle at the center, is 2 times the angle at the circumference. So the angle at the center is twice the angle at the circumference. I also went ahead and explained that there are a lot of ways we can write this. Mathematically, if we want to represent this, we say the angle at the center. So I said don't go and follow any rules to make it complicated for yourself. The angle at the center is, so the angle at the center is mentioned first. So go to your diagram and look at which angle is subtended at the center. So you realize that from what we have here, this diagram, angle O is the one that is subtended at the center. Or you can say POQ, or angle QOP. I told you in your previous class that angles are named in a clockwise or anti-clockwise way. So angle at the center, which is angle O, so angle POQ. So the angle at the center is, and I said in mathematics, anytime you see the word is, we use equal to. So is means that put equal to over here is twice, so twice 2. The angle at the circumference. Which one is the angle at the circumference? You realize that the angle at the circumference is the angle R. R is the one at the circumference. So either P, R, Q, or Q, R, P. So the angle at the center is twice the angle at the circumference. So angle P, R, Q. The angle at the center is 2 times the angle at the circumference. So just take your time, follow the words one after the other. The angle at the center. So go and look for the angle at the center. This is the angle at the center. You put it down as I've done. So POQ is in mathematics we use equal to. So is twice is 2. So 2 is twice the angle at the circumference. Angle at the circumference is angle R, PRQ or QRP. So it's twice angle PRQ. Again, we take a look at this diagram. we want to look at the theorem 1. Still looking at theorem 1. We are looking at angle subtended at the center and its connection with angle subtended at the circumference by the same chord. Now in this diagram, as I explained during our last class, you realize that in this diagram the chord has not been drawn for you. The chord is not drawn. But from our definition of chords, we explained that a chord joins 2 points on the circumference of a circle. So I have point X and I have point Y. So because X is a point and Y is a point, I can join the 2 points to form a chord. Because any line which joins 2 points on a circle, on the circumference of a circle, is called a chord. So I can join point X here to point Y. Now if I join point X to point Y, then it means that this line XY is now a chord. Now let's look at the angles that are subtended by the chord XY. Remember, I've told you, you look at only 2 places. Either it is subtended at the center or it's subtended at the circumference. And we use only chords to subtend angles. I've already explained that. Don't go and see radius and you say you want to use the radius to subtend an angle. We use only chords and arcs. But I want to use only the chord. Okay. Now let's look at the chord XY. Chord XY is subtending angle O at the center. Because if you look at the lines which create this angle O, there is one line at X, the other line is at Y. So XY is subtending O, and O is at the center, so it subtends O at the center. If I look at the same XY, and I look at the angle Z, you realize that for angle Z, one line has a connection with point X, the other line has a connection with Y. So you realize that XY here is subtending Z at the circumference. So look at the chord XY and follow the line which creates the angle Z. So you realize that the 2 lines have a connection with line XY. This line have a connection with X, and this line have a connection with Y. So chord XY is subtending Z at the circumference. So one chord, XY. XY is subtending O at the center, and the same XY is subtending Z at the circumference. So one chord subtending 2 angles, one at the center and one at the circumference. What it means is that there is a connection between the 2 angles, the one at the center and the one at the circumference. And we say the connection is that the one at the center is twice the one at the circumference. The angle at the center is twice the one at the circumference. So I'm going to put this connection down mathematically. So the angle at the center. So first I need the angle subtended at the center. This is the angle which is subtended at the center. That is angle XOY or YOX. So YOX or XOY, that is the angle subtended at the center. So angle XOY, so the angle at the center is we use equal to. So it's twice, so twice, 2. The angle at the circumference is angle Z. X, Z, Y, or Y, Z, X. So it's twice angle X, Z, Y. The angle at the center is 2 times the angle at the circumference. The angle at the center is twice the angle at the circumference. let's try and identify the connection between the two angles. Now let's take a look at the name given to the line SR. Now I realize that the name for the line SR, we've already explained that that is a chord. Why is SR a chord? Because it joins point S to point R. So the line SR is a chord. Now let's look at the angles that the line SR subtends. Line SR is subtending O at the center. Follow the lines. Look at the angle O, this angle here at the center. The two lines which creates the angle is this line and this line. Now if I follow the line, realize that this line has a connection with a point S. This line here also has a connection with R. So look at SR. If you follow the two, SR is holding O at the center, or is subtending O at the center. Now look at the same SR. If you follow this line, you realize that SR here is holding T at the circumference as well. Now we say if it is holding it, the two lines should have a connection with the chord. So if you look at chord XR, look at the lines which create the angle T, this line. It has a connection with S, and this one has a connection with R. So SR is subtending or holding angle T at the circumference. The same SR is holding or subtending angle O at the center. So one chord SR is holding O at the center. The same chord SR is holding T at the circumference. So it means there is a relationship, or there is a connection between the two angles, the one at the center here and the one at the circumference. And the connection is that the one at the center is 2 times the one at the circumference. The one at the center is mentioned first, so put that one down. So angle at the center, angle SOR, is twice the angle at the circumference. Angle at the circumference is angle STR. Now, what we are going to do now is look at the mathematical way of getting the questions now. We are now going to look at the calculating aspect. So how to calculate. Now, before we do calculation, let me explain something to you. A quick recall. Now, you remember I've told you the triangle here is always an isosceles triangle. And we did explain. I told you that this line here, OX, the distance from the point O to the point X, a line from the center to any point on the circumference, we say that line is called a radius from our definition. So the radius is always a straight line from the center to any point on the circumference. So we realize that OX here is a radius, and OY is also a radius. And I told you that they are always equal in length. So this line here is equal to this line. Because these two lines are equal, we concluded that triangle XOY becomes an isosceles triangle. We said isosceles triangle is any triangle in which two of the length of sides are equal. So if this length and this length are equal, we also concluded that then the base angles are also equal. So that the angle here and the angle here will be equal. So if this angle is A, then this angle is also A. The same thing, if we come to this diagram, if we look at the name given to the line OS, the distance from O to S, that is a radius. OS, any line from the center to the circumference is a radius. The same way OR, the line OR is also a radius. So this length and this length will be equal. If this length and this length are equal, then the triangle here, SOR, this very triangle, becomes an isosceles triangle. So that the base angles here will be equal. The angle here and the angle here will be the same. In actual sense, this triangle is also an isosceles triangle. This is also isosceles, but we'll look at that one as we move on. I don't want to pile things up on you. So you realize that OT, the name for the line OT, the point O and the point T, these two lines, when you join the line joining the 2 points, you realize that this line is also a radius, a distance from the center to this point. So if this is a radius and this is also a radius, then this length and this length will also be equal. So that triangle ROT also becomes isosceles. But then let's look at the basic ones first. So let's look at question 1 or example 1. So related questions, we are looking at example 1. Find the size of angle ROP. In the diagram, PQR are points. on the circle center O and RPQ equals 28 degrees, find the size of angle ROP. Find the size of angle ROP. So first of all, ask yourself, which angle are we trying to find? Which angle are we trying to find? First, you have to find the angle that you are looking for. So the angle that I'm looking for is the angle ROP. So I'll follow the points to look at the angle. So this is R, this is O, and this is P. When an angle is written like this, it means the angle is at the center. So ROP means that the angle at O. The angle at O. So I want to find the angle at O. Then you ask yourself, what is angle at O? Is it angle at the center or is it angle at the circumference? Now you realize that the angle O here is the angle subtended at the center. So let's look at the chord which subtends the angle O. I'll follow the lines which creates the angle O to locate the chord. So I'll follow this line. So this line has a connection with point P. And then I'll follow this one. And this line OR also has a connection with the point R. So if I take a look at the angle, the line PR, the line PR is holding or subtending the angle O at the center. I will check again to see if this PR is subtending an angle at the circumference. So look at the angle at the circumference, angle Q. Let's see if PR is subtending the angle at the circumference. If it's subtending it, the lines which create the angle should have a connection with PR. So the first line is this, I'll trace. So you realize that the first line has a connection with P. I'll trace the second line. I realize that that one also has a connection with R. So look at the chord PR here. Chord PR here is subtending Q at the circumference. The same QR, PR, the same PR is subtending O at the center. So one chord, PR, subtending Q at the center. The same chord, PR, subtending O at the center, at the circumference. Let me take it once again. So PR here is subtending Q at the circumference. PR here is subtending O at the center. So there is a connection between the angle at the center and the angle at the circumference. I've told you, don't be in a haste to write your answer. You get it wrong. Just take your time. You've now been able to see that there is a connection between the angle at the center and the angle at the circumference. So just follow the theorem to write your answer. Just follow the theorem. The theorem states that the angle at the center is twice the angle at the circumference. So take your time, write down the theorem before you start substituting your values. So the connection is that the one at the center, so I know the angle at the center is the angle ROP or POR. Any of them is accepted. So angle ROP, which is angle at the center, so that is our solution. Angle ROP is, so S we use equal to, is twice. So the angle at the center is twice the angle at the circumference. The angle at the circumference is angle Q or RQP. RQP or PQR. So it's twice angle RPQ. Then from this connection, you will now look at which of the angles have been given to you. You substitute it into the equation, then you write down your answer or you calculate for your final answer. So you realize that the angle at Q has been given to us, angle RQP. So if I come here, this angle RQP So this angle here, RQP, has been given to us as 28 degrees. So angle ROP is equal to twice 58, 28. We point this on our calculator, we write down the answer. So angle ROP will be equal to 56 degrees. So this angle here is 56. The one at the center is twice, 2 times. So you realize that when you multiply this 28 here by 2, it will give you the one at the center here straight away. So for those who want to do or use the shortcut as an objective question, when you see this is 28. The one at the center is 2 times the one at the circumference. So just take the one at the circumference and multiply it by 2. It will give you the one at the center. So 28 times 2 here will give you this 56. Now let's look at example 2. MTN are points on the circle center O. MTN are points on the circle center O. If angle TON equals 78 degrees, So all that they are saying here, you realize that it is on the circle over here. M, T, N are points. So you have the point M, you have the point T, and you have the point N. So they are points on the circle. So as you can see, they are on the circle. And then it also says that the center of the circle is O. If angle TON, so if you follow point T, point O, and point N, so angle at O, if the angle at O is 78 degrees, find the value of angle NMT. Find the value of angle NMT. So NMT means that the angle at M, the one in the middle, that's what we are looking for, NMT. So I will follow the points. Point N. So this is point N. This is point M. And this is the point T. So I want to find the angle over here. Again, I said first of all, before you answer, ask yourself, the angle that you are finding, which angle is it? Is it the angle subtended at the circumference, or is it the angle subtended at the center? Now you realize that this angle M here is subtended at the circumference. Which chord is subtending the angle M? We have to get a chord. If the chord is subtending the angle M, then I said the chord should have a connection with the lines that create the angle M. So let's follow angle M, the lines which creates the angle. Now two lines create angle M, this line and this line. So I will follow them. It is this line and then this line. Okay, so these two lines, this one and this one, they create the angle M. You realize that this line here have a connection with the point N, and this line here have a connection with the point T. But you realize that the chord is not in the diagram. So in this case, you have to introduce the chord into the diagram. You have to bring the chord. So I will introduce my chord into the diagram. I will use dotted lines, broken lines, or short dashes, any name you call it. So now you realize that the chord MT here is holding the angle M, or is subtending the angle M at the circumference. So chord MT subtends angle M at the circumference. You also notice that this angle O here, the two lines which creates the angle O includes this line and this line. And these two lines also have a connection with a point N and a point T. So chord MT here is also subtending the angle O. So one chord MT subtending two angles. MT is subtending M at the circumference. The same MT is subtending O at the center. So there is a connection between the angle at the center and the angle at the circumference. And the connection is that the angle at the center is twice the angle at the circumference. Once again, don't be in a haste to write your answer. Follow the theorem, write down the connection between the two angles first before you answer. Now the connection between the two angles is that the one at the center is 2 times the one at the circumference. The one at the center mentioned first. So put down the angle at the center. Now the angle at the center is angle NOT or TON. They are all the same. So the angle at the center, angle TON, is twice the angle at the circumference. The angle at the circumference is the angle M. So angle NMT, or somebody writes TMN. They are all the same. the angle at the center is twice the angle at the circumference. So I've been able to write down the connection between the two of them. Now these two angles, one of them will be given to you to find the other. Now check from the diagram. From the diagram, you will notice that one of the angles have been given, which is the one at the center. The angle at O is 78. So this angle here, TON, this angle is 78. So this has been given to you. So this implies 78 is equal to twice angle NMT. Now what we do here is that we solve for the angle NMT. Now I'm looking for angle NMT, but I have 2 in front of it. So we all know what we have to do. We have to remove the 2. So remove the 2 by dividing both sides of the equation by 2. So I'll divide this side by 2 and divide this side also by 2. This will cancel that. 2 will go into 78 39 times. So this is 39. Angle NMT equals 39 degrees. Now in example 3, I'm going to move a step further. I'm going to ask you to calculate about 2 or 3 of the angles, and I'll give you 2 minutes to go through and see if you'll be able to answer on your own. After the 2 minutes, I'll come and then present you with the answers. Then you cross-check and see if you were able to arrive at the right answer. So let's look at question number